Unit 4, Lesson 4, Example 3. This will be the flow proof example. So again, they've asked us to do a proof, so we're going to start by listing our methods that we have. We have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. So we're going to annotate our diagram with the given information. AD is perpendicular to BD, so we know that there will be a right angle here. BD is perpendicular to BC, so we know there will be another right angle there. And they give us that AB is congruent to DC. So they didn't tell us about any of the other sides on here, like AD and BC, so we know side, side, side is going to be out. We can't get those third sides there. Additionally, we only know about these right angles, so we're not going to be able to do anything with the other two angles. We don't have parallel lines. They didn't tell us anything about the other angles. Again, we can't make assumptions here. Side, angle, side, that angle has to be sandwiched or in between the two sides. AB does not lie next to this right angle, so that's out as well. However, we can use hypotenuse leg because we do have right triangles. Yay! So that's a good thing. Okay. So let's get, I'm going to get my final statement on there at the bottom. Triangle ABD is congruent to triangle CBD. And that is going to be by hypotenuse leg. I already know that. I've deduced that from my given information. And so let's see what else. So they gave us that AB is congruent to DC, and these are the hypotenuses of the right triangles. But keep in mind, remember what we said, that in order to use hypotenuse leg, we must state that these are right triangles in our proof. And we need a leg on each of these. They told us nothing about AD, nothing about BC, but we can see that BD is congruent to itself. So I can get the leg. BD is congruent to BD by the reflexive property. Okay, so now I just have to work on using the rest of the other information that they gave us. Which would be, so let's see, they gave us that AD perpendicular to BD, BD perpendicular to BC, and in the same statement I can say what else they gave us. Given. Okay, so what does AD perpendicular to BD and BD perpendicular to BC tell me? That tells me that I'm going to put a 1 and a 2 here. Angle 1 and angle 2 are right angles. And that is definition of perpendicular lines. Okay, so if those two angles are right angles, then we know that triangle ADB and triangle CBD are right triangles. How do we know that? Definition of a right triangle. And so they already gave us this, which we now know is the hypotenuse. And so we have hypotenuse leg, so we can just go down. Again, in order to use hypotenuse leg, you must state in your proof that triangle ADB and CBD are right triangles, because again, only right triangles have a hypotenuse. If we were to label this with the information we have, remember that would give us side-side angle, which is not a valid approach. We cannot use that. However, because this is a right triangle, we can use hypotenuse leg in replacement of that method, which we cannot use. So let's look at the final question down below. Identify the rigid motion or motions that will map one triangle onto another. So here we're going to need a sequence. So I chose to rotate about B 180 degrees, which puts me here. So a rotation centered at B, 180 degrees, will put me over here. And let's see what else. And so then I would need to translate my figure from B to D. So followed by, we could have rotated about the midpoint of BD as well. That also would have worked. Followed by a translation. And I can say mapping B to D, or I can just write a vector BD. We could also say, or a rotation, 180 degrees, centered at the midpoint of BD. That would also be an appropriate rigid motion that would map those two triangles together.